I audible? Astha, Alan, Rehan?
Yes, ma'am.
All right. So in the last class, I think we had just stopped at the point where we derived the mirror formula. Then I think we couldn't complete anything else. Let's just complete mirror formula. Let's practice some numericals on it. See, mirror formula was simply 1 by f is equal to 1 by u plus 1 by v, right? Where you have to put in the sign conventions. One more thing that was left and yet to be discussed was linear magnification. All these points we had done, we divided by UVR to obtain this final equation, and here you have to use the sign convention. One topic that is left is linear magnification. So what is meant by linear magnification? Linear magnification is simply height of image by height of object. This is height of image by height of object. So HI here means height of image. And HO or H naught you can say is height of object. Now the derivation which we were doing, no, using that only you can figure it out, the formula for this. See, using this mirror, we concluded the fact, no, that this triangle A dash B dash P and ABP, this bigger triangle and this smaller triangle, both are similar to each other. This triangle, as well as this triangle, they are similar to each other. Why? Because of this angle I with angle R and this common side. So using that similarity, we had this similar. Remember here we did it, this step. Now using this only, we will figure it out. What will be the linear magnification? So if you are asked to write about linear magnification in your examination, then you have to draw that figure, because we are writing it in the continuation of that figure only. Fine. So whenever in your exam also you are asked to write about the linear magnification, though the derivation will usually come for the mirror formula only, but if just in case it comes, no, then you have to draw that figure and directly start. Linear magnification is ratio of height of image by height of object, and in the figure triangle APB is similar to triangle A dash PB dash, and from here you can conclude that A dash B dash by AB is equal to what? B dash P by BP. This was the line that was already discussed in the last class. If you're still having any issues, no, let me know. Now see, A dash B dash was what? The image that was formed. A dash B dash was what? This is the image that is formed, no? So A dash B dash is this length. If you look here, this is A dash B dash. So if this is A dash B dash, then this means this is the height of image. This becomes the height of image. And AB is the height of object. So AB is height of object, A dash B dash is height of image. So will we take height of image as positive or negative? We did the sign conventions. So will we take it as positive or negative? Yes, anything that is kept below the principal axis, we take it as negative.
Negative. Yeah.
Yes, Alan, right. See, anything that is kept below the principal axis, let's take it as negative. Be it height of image, be it anything. Fine. Usually you have height of images only that is taken negative, because obviously objects are always kept above the principal axis. So this term is what? This term becomes negative. Two more things we had, no? B dash P and BP. See, B dash P is the image distance V, and BP is the object distance. Both are kept in front of the mirror. If you have anything in front of the mirror, what do we say? Anything that is in front of the mirror, we say that is also negative according to the sign conventions. Now see, so what will your final linear magnification be? See, A dash B dash will be minus I, height of image. AB will be plus height of object. B dash P will be negative of image distance, and BP will also be negative of object distance. This will also be negative of object distance. Fine. Now, if you keep it here, a dash b dash by ab, you will observe that this is minus height of image by height of object is equal to minus v by minus u. It means magnification becomes what? Height of image by height of object is equal to, this minus sign will come here, minus v by u. This is the magnifications formula. This is the magnifications formula. This formula that we are obtaining over here, m is equal to hi by h naught is equal to minus v by v naught, basically. Fine, this is the formula for it. Now, class, apart from this, there are some details that you have to remember for magnification. How? Because from your linear magnification, in your exam, no, you'll get a complete question. I'll show you also. We'll do that. We'll practice that question right now. What will happen? You will get a specific question on image distance, object distance, focal length, any question regarding that will be asked to you. Also, after this, it will ask you what is the size of image, what is the nature of image, what is the position of image. So position you can calculate using mirror formula, but what about the rest of the details? How can you calculate it? By just looking at it. So by just looking at it, you can calculate in such a manner that your linear magnification, I'll show you. So this is the definition. Ratio of height of object to that of height of image is called linear magnification. Then yes, this is also known as transverse magnification and is denoted by small m. M is used, you can also call it as transverse magnification. So if somehow in your exam, instead of the term linear magnification, transverse magnification is used, so do not get confused. Transverse magnification, even if it's used, it means linear magnification. Fine. Now, in the formula, no, m is equal to minus v by u. This formula that we have m is equal to minus v by u. Suppose you have focal length given and you have object distance given to you. These two terms are given to you, focal length and object distance. So if two such terms are given to you, image distance is not given. So how will we calculate magnification then? For that, you can simply use the mirror formula. 1 by f is equal to 1 by f will be equal to what? 1 by f will be equal to 1 by v plus 1 by u. So even if you have focus and object distance, you can calculate image distance. Keep it in this formula. Or you can do one more thing. You can directly use this f by f minus u. Because when you will do and perform all these steps, same result you will get, exact result you will obtain. Similarly, if you have, let's say, object distance is not given, image distance and focus is given. Same thing use, same thing apply. So that will be f minus v by f. So this can be used directly also if you think the question is of 5 marker, 3 marker. So instead of just writing it simply, you show the steps how you have got this using this. Now coming to the theory part, which is very important from magnification. Do mark that important, much more important, the formula of it. Now see. Firstly, first conclusion regarding the magnitude. Magnitude, do you people understand? Magnitude means no sign is considered. For example, if I say minus 3, so magnitude will be 3. You ignore the negative sign that is present. Positive sign is there, negative sign is there, that is not your concern. Magnitude means just the number term, numerical term that is present. All right, so you will look at the magnitude. Suppose let's take this example only, m is equal to minus 3. So what is the magnitude in minus 3? Just the number 3 is the magnitude. Now, if you get the magnitude greater than 1, it means your image is magnified. If you get your magnification's magnitude less than 1, it means it's a smaller image than the object, or diminished image, you can say. If you're getting magnification's magnitude exactly equal to 1, so image will be of same size. So if I say minus 3, so you will just focus on 3, and 3 is greater than 1. Please, class, focus that this is the magnitude. Do not say minus 3 is less than 1. Definitely minus 3 is less than 1, but we are not considering minus 3. What are we considering? We are considering just the magnitude. So it means 3 is greater than 1. So it will be magnified. Fine. And now regarding the sign, you will analyze the sign separately. If the sign is positive, the sign of it is positive, it means it is a virtual and erect image. If your sign is negative, it means it's a real inverted image. Now coming back to the example, m is equal to minus 3. 3 shows you that image is magnified, and minus sign shows you it's real and inverted. So let's say a question is given to you. At the end of question, nature and size of image is asked. If you just calculate magnification like this, you're getting minus 3. So what answer can you write? Image is magnified, real, and inverted. With just the theory portion, no, you were able to write all these facts. So by looking at it, by looking just at the magnification's magnitude and sign, you can figure out so many things. So let's take the example. Let's start with you, Alan. I'm saying magnification is minus 1. So what will be the size of image according to you?
Ma'am, it's enlarged and it's real.
Minus 1.
Oh, ma'am, I'm sorry, it's the same size and
Same
then
sign.
it's real.
It's real and inverted and of same size. Good, Alan. Astha, if I say magnification is minus 3.4, what will be the characteristics of image?
It will be magnified
Hmm?
and real and inverted.
Real and inverted. Good. Rehan, if I say the magnification is plus 0.5, so what all conclusions can you draw?
It's
Plus?
diminished
Yes. Yes.
and virtual and erect.
Perfect. Good, Rehan. Because it was 0.5, less than 1 was the magnitude, and plus sign shows virtual and erect. All right, class. Razan, I hope I'm audible to you. So just write down all the points of linear magnification. We'll do numericals and we'll complete with this topic at least. So your reflection will be completed then. Okay, so let's practice this question. So this is a question from your NCRT only. An object is placed 10 centimeters. First part says 10 centimeters. Second part says 5 centimeters. Let us take this 10 centimeters first. So object is placed at 10 centimeter in front of concave mirror. It means this is what? Object is placed in front of it. It means this is your object distance only. If this is your mirror, here is your object placed 10 centimeters. So we'll write object distance. Now this will be minus 10 centimeters. Fine, class. We'll just have to do not use the sign convention at one single place in the entire ray optics. That is your optical instruments. When we'll reach that portion, I'll tell you. But anywhere else, lens formula, lens maker formula, mirror formula, all these parts that you have to apply sign convention. That's why we did sign convention last weekend. Yes, and radius of curvature. So here the radius of curvature will lie. So we require focal length, and focus was radius of curvature by 2. This derivation also comes. Remember, we did it. So this becomes 15 by 2, that is 7.5 centimeters with a minus sign, because here also focus is in front of it. And then it says find the position. Yes, this type of question I was asking you. Position, it means U and F are given. Image distance is what? Nature, real, inverted. What type of nature? Size is missing here, otherwise size is also asked, and magnification in each case. So definitely for finding out the nature, you have to find out the magnification. Nature of image can also be given by position of image. If your image comes out to be negative, that can show it is in front of mirror. But rest of the minute details will be given by magnification only. See, let us find out image distance first using this. See, 1 by f is equal to 1 by v plus 1 by u. And 1 by v will be equal to 1 by f minus 1 by u. Now, using the appropriate sign conventions, put it, though we have taken the sign conventions here already. So this becomes 1 by minus 7.5 minus 1 by minus 10. So that makes it minus 2.5 by 7.5 into 10, right? So this will get cancelled. Minus sign will there. Minus 1 by 3 into 10, that is 30. So image distance comes out to be minus 30 centimeter. Minus 30 centimeter. This minus sign, I have not added it by myself. This minus sign is showing you that image is formed 30 centimeters in front of the mirror. Fine. This is showing you that this is image has been formed in front of the mirror. Now, if we calculate the magnification, simply use minus v by u. So minus v, this is, now here also you have to use sign convention. This minus is from the formula. Now putting v, I'll write minus 30. It's not like here minus sign has already been written, so no need to place this minus sign. No. If even though any sign is placed, that is a part of formula. You have to by yourself keep the sign conventions. And then object distance is also minus 10. So this makes it minus 3. So image is what? See, 3 is giving you that this is magnified, enlarged, greater, big, any term you can say. Negative sign is showing you the fact that this is real as well as inverted. And where the image exactly is formed, that is 30 centimeter in front of the mirror. How? Because minus sign is there. Like this you have to do. Note it down and try this second part by yourself. Everything will be the same. Instead of 10, you have to take 5. 5 centimeters is the object distance. Try this yourself. Firstly, note this down and then try that. So this is a standard question. These types of questions do come in your exam. See class, if you in the second part take no object distance is -5. Did anyone get any answer? See, if object distance you take it as -5, the rest of the things will remain the same. 1 by v will be equal to 1 by f minus 1 by u. So this will be equal to -1 by 7.5 minus 1 by -5. So that will be -5 into minus. So that will become plus 7.5 and this will get multiplied. So 7.5 into 5. This becomes 1 by 15. So image distance is plus 15 centimeters. It means now your image is formed where? Now your image is formed where? Image is formed 15 centimeters behind it. 15 centimeters behind the mirror. Understood? That's why you have this positive sign. Now, if you take the magnification will be minus v by plus u. So minus v means -15. U is already negative. That is -10. Right? This was what we had. No, not 5 now. Object distance is 5 now. No. So that becomes +3. This is 5, so this becomes +3. Now this shows what? 3 shows you again the fact that this is magnified. But what does plus sign shows? That this is virtual and erect. So like this in the board exam also you will be getting questions. Similarly, you have to solve it like this only. And at this time, don't make these arrows in your final answer in exam. Write it in words. Image is formed 15 centimeter behind the mirror. Image is magnified, virtual and erect. All right, note down the second part. So now class reflection is over. Let's quickly revise what is refraction. Before we start with refraction, no, one topic is there that is very important topic, refractive index. So first we'll do refractive index, then we'll go into the details and the theory part of refraction. Now see what is meant by refractive index. See, normal density you are all aware of, the density that is present, density of copper, density of brass, all these densities you are aware of. Now see, what happens is that for glass's optical density, we use the term refractive index. How much optically denser a material is. It means how much amount of light it allows by itself, how much amount of light it allows to transmit, to refract, to absorb. So that optical density is defined by refractive index. We say like glass is denser, air is rarer. So the material that has a greater optical density, we call it as denser material. And the material that has a little lesser optical density in comparison, that is known as rarer. So we say air is rarer and glass is denser. Fine, denser and rarer, these two things will be used a lot. That's why I mentioned. Apart from this, optical density. So this is clear, I hope. Optical density, don't consider it as mass by volume. That is a different density. Otherwise, density of glass is same. So every material, every lens should have the same optical density. This is not the case. No, because this is different. Optical density here, the optical density is completely different. Optical density means how much refraction is allowed, how much reflection is allowed. These phenomena, it is measured in that term. Now, so this is for your understanding. Now coming to the fact what actual refractive index is and what is the mathematical definition of it. So mathematical definition, no, it's very easy. Just remember right now only. Ratio of two velocities or ratio of two wavelengths. Fine. Ratio of two velocities now and ratio of two wavelengths. This is how you can remember it. Now, if your one medium becomes air, somehow your one medium is air, another medium can be anything. But your first medium, this is air, right? Your first medium is air. Then, and second medium is some medium that is unknown. But one medium, you are aware of the fact that yes, this medium is air. Other medium, you're unsure about it. No need to go into the detail of the second medium. But one medium, you are aware that this is air. So that type of refractive index that will be obtained, that is known as absolute refractive index. Absolute refractive index. So now it becomes ratio of what? Ratio of speed of light in air by ratio of speed of light in that medium. Similarly, ratio of wavelength in air by ratio of it in that medium. This is what is meant by optical refractive index. If both the media are unknown to you, you are unaware. If it is not air, some other medium is there, unaware means it is not air. Then the refractive index which you obtain, that is known as relative refractive index. Relative, no, two things are in relation with each other. You are comparing it with the other medium, like glass and water. So here you take the relative refractive index, glass and water. But if you're taking glass with respect to air, that becomes absolute refractive index. Now I will show you. Look at the definitions of it. Yes, okay, it's on the screen only. Refractive index of a medium of a light of a given wavelength may be defined as ratio of speed of light in vacuum to its speed in that medium. It defines the optical density of a medium and it is divided into two types. Either it can be absolute refractive index or it can be relative refractive index. Absolute refractive index is what? Absolute refractive index is speed of light in air, and speed of light in air, you know. That's why you can make comparison because this quantity you are aware of, speed of light in air. So it is either refractive index is denoted as small n or this symbol mu, u with small h's. This symbol we use it for coefficient of friction. If you remember, you must have done it in your class 11. So n or this symbol mu. So speed of light in air, that is fixed. This is fixed, 3 into 10 to the power 8 meter per second. Or speed in some other medium. Or this is equal to wavelength in air by wavelength of light in the medium. This is in the medium. This is what is meant by the absolute refractive index. Now, in case of relative refractive index, both the things are unknown to you. So it means N, or you can say N or mu, this is equal to V1 by V2, which is equal to lambda 1 by lambda 2. Now, nothing is air in this. It can be any medium. Any medium. You take oil, you take water, you take alcohol, you take glass, any medium, but not air. Fine. As soon as air will come into action, the category of relative index will become convert into absolute. So this is V1 is what? Speed of light in medium 1. V2 is what? Speed of light in medium 2. Lambda 1 is what? Lambda 1 is wavelength in medium 1. What is lambda 2? Lambda 2 is wavelength in medium 2. Fine. This is, I hope this part is clear. This is not very difficult. But more often, this will be used in your numericals. What happens? Sometimes two refractive indices are given. Then what? This is the formula, no, for calculation of refractive index. So you can calculate using wavelength, velocity, whatever. Let's say the refractive index of air is given, refractive index of glass is given. Then what will be the net refractive index? Different refractive indices are given. Then how will you calculate it? Right. So for that, we divide it, like we write it N2 by N1. If I write now N2 by N1, that means refractive index of second medium with respect to the first one. That means refractive index of the second medium with respect to the first one. All right, this is how we write the refractive index for it. So if I write N1 by N2, N1 by N2 becomes N12. That is refractive index of first medium with respect to second. So this is how you write the refractive index. So N21 means refractive index of second medium with respect to first one. So N2 by N1. If I write N12, refractive index of first medium with respect to second medium, N1 by N2. Similarly, if I want to write NDR, refractive index of denser with respect to rarer, so ND by NR. If I say refractive index of glass with water, NGW, refractive index of glass with water, that becomes NG divided by NW. This is how we write it. That's what I'm trying to explain, how to not get confused between N21 and N12. Note it down, we'll see numericals on it, refractive index, then this will become clear. Is it clear till here, right now? Yes, class?
Yes, ma'am.
Yes, ma'am.
Okay. Factors on which refractive index. See, factors on which the refractive index depend becomes firstly the nature of the medium. As you can see, because of different medium, you're having different values. It depends upon the wavelength of the light used. Wavelengths are different, no? For red, like red, you have the highest wavelength, violet, you have the least wavelength. And it also depends upon temperature. It depends upon the nature of the surrounding medium as well. Fine. Remember one thing, it is independent. It may be, you can note the fact that the pair of media is there. It depends on the wavelength of light, but it is independent of angle of incidence. So apart from this, rest of the things that you're able to see in the formula, no, that will be used. Clear? Okay. Okay, did anyone get any answer? See, this says what? Light of it. How much you're getting? Or yes, the initials are right. Powers of 10s are better. I'll show you. See, light of wavelength 6000 angstrom in air enters a medium with a refractive index of 1.5. Fine. This is refractive index is 1.5. Now see, what is the frequency and wavelength of light in that medium? In this medium, what is the frequency and wavelength? So refractive index is given to you as 1.5 and the wavelength is given, wavelength in air, lambda naught is given as 6000 angstrom. How do we convert angstrom into meters? Class? How do we convert?
10 raised to minus 10.
10 raised to minus 10. Yes, good. So this becomes 6 into 10 to the power 3, 6000 into 10 to the power minus 10. Yes, right? 6 into 10 to the power minus 7. This will become meters. Now, if wavelength in that medium, so wavelength in air by wavelength in the medium. So wavelength in the medium will become what? Wavelength in air by divided by refractive index. So this becomes 6 into 10 to the power minus 7 by 1.5. So this will come around 4,000 angstrom. 4,000 angstrom. Just check the answer one. I have not solved it right now. I just remember the answer, so I have written it. Just check it once if it is 4,000 or not. It should be 4,000 angstrom. Then it says frequency as well. Now see, regarding the frequency, remember, when light travels from air to the refracting medium, frequency remains unchanged. Fine. So it does not mean that you have to find out the frequency in air and that medium. Both will be the same. But what will it be? See, velocity, speed is always equal to frequency multiplied by the wavelength. So frequency becomes equal to speed divided by the wavelength. And what is the speed? Let's take the speed of air because at least one medium we are sure. So speed of light by wavelength, 3 into 10 to the power 8 meter per second by wavelength is 6 into 10 to the power minus 7. So this becomes 5 into 10 to the power 14 hertz. This is the frequency. So this frequency is valid for air as well and in that medium also. Why in that medium also? Because this won't get changed. This will not be changed. All right, frequency remains unchanged. Remember this fact. This remains unchanged. But wavelength and velocity changes. Velocity changes, that's why you have refraction. We'll see. How much time is it? Yes, we'll see right now. Just copy it down. Then we'll discuss some portions of refraction. All right, class, let's discuss the basics of refraction. See what is meant by refraction. Refraction is the change in the path of light. For example, if a ray of light has to travel like this, or let's talk about this light that is present. This light rays, the light rays of this bulb that is present, these are passing straight away. Fine, these are passing directly straight away. There's no bending because the medium remains is the same. That is, air is there. Here also air was there. Here also air is there. Here also air is there. That's why. So if somehow the velocity is changed, let's say this is the ray of light that is coming. Let's say this part enters in a different medium where velocity changes. So it will slowly move. So somehow you will observe an angle which was initially like this, straight away coming. Now what is happening? There's a bending in the path of light. So this phenomena is known as refraction. Also, by the definition, the phenomena of change in the path of light as it passes obliquely from one transparent medium to another is called refraction of light. Why transparent medium? Because only transparent medium will allow the light rays to fall through it. No, otherwise, if it's a reflecting medium, then the reflection phenomena will occur. If it's an opaque medium or a black body material, so it will absorb the ray of light. So for transmission to occur, this has to be done. Fine. All right. Yes, so incident rays there, this falls at this surface. Let's say this is one medium, this is second medium. This occurs, and this is perpendicular. Normal, we have already discussed, same normal. This is your plane surface, a perpendicular dropped on the surface. Fine, a perpendicular dropped on the surface. Exact perpendicular dropped on the surface is known as normal. So here also normal will be drawn. So this angle I will become angle of incidence right now here. Do not take it from the plane surface. I'm again repeating, take it from the normal always. And this is the refracted ray, and this becomes angle of refraction. So the original path of the incident ray was somewhat like this. Now it has deviated. Can you notice there's a deviation in the path? This is known as refraction. The way we had laws of reflection, or two laws of reflection were there. What were the laws? Angle I is equal to angle R, and all the three rays lie in the same plane. Here, one of the laws will remain the same. That is incident ray, the normal, and the refracted ray. Incident ray, the normal, and the refracted ray all lie in the same plane. Fine, all of these lie in the same plane. So yes, first law says that, first law, the laws of refraction, phenomena of refraction of light obeys two laws. First law says incident ray, refracted ray, and normal to the interface at the point of incidence lie in the same plane. So basically, this is because cause of refraction lies in change of speed in medium. Change in the speed in that medium. Second is very important. This is the second one. This is very important, known as Snell's law. Why is this important? When you will notice down the formula, the formula is very simple. It's very straight. But the application of this formula is there. The questions will not be asked to you in the exam. There are chances, slight chances are there that direct questions can also be asked. But maximum time, direct question on this cannot be asked. But till the end of the lesson, even when we will be doing prism, this Snell's law will be applied at so many points in your lesson. In the derivations also, there will be application of Snell's law. So please understand how to apply Snell's law. Now see, Snell's law is what? This says that suppose this is a medium, ray of light is incident on it. This is the normal, angle of incidence is there. This gets refracted, angle of refraction is there. Incident ray is there, refracted ray is there. Let's say refractive index of this material is N1, this material is N2. So this mainly says sine of I by sine of R is equal to N2 by N1. This is what is your Snell's law. This is your Snell's law. But now sometimes it becomes confusing whether to write N2, whether to write N1, what is N1 for me, what is N2 written in the question. That can be confusing. So best way to write this statement is take the refractive index of that material multiplied with the sign of the angle given in that medium is equal to refractive index of the medium multiplied by sign of angle that is given in the medium. So this will become what? N1 refractive index of that material into sin I is equal to refractive index of the material into sin R. And so on. Even if so many steps are there, so many calculations are there, even if it is repeated, write it as it is. Now see, if you rearrange sin I by sin R, you will get it as N2 by N1, or you can say N21 as well. So that's how you can write it. Okay, note it down then. These are the two laws of refraction. Laws of refraction can be asked during the exam directly. It can be asked. Any doubts you have, please let me know.
Ma'am, can you scroll up?
Completed?
Yes, ma'am.
Okay. See, when light travels from rarer to denser medium, it means this is the rarer medium. This is the denser medium. Now, this is the path of incident ray. Now, what will happen? This has to be refracted. But how will you refract it? Towards the normal or away from the normal means? See, this is the original path of the incident ray. This is going away from the normal. And this is going towards the normal. Did you notice? See, I'm repeating this. If you have this ray of light, fine. If this ray of light bends like this is known as going away from the normal. If the path of incident ray is like this is going towards the normal. Fine. So if a ray of light travels from rarer to denser, this is angle of refraction, this is angle of incidence, this is the normal. Now, how will you prove? How will you prove this fact that yes, this is bending towards normal? This can come in your theoretical questions. That's why I'm saying this. The proof is there. Let's say this is N1, let's say this is N2. Sine I by sine R is equal to N2 by N1. When we say the medium is denser, for a denser medium, N2 becomes greater than N1. Fine. So if N2 becomes greater than N1, we can say N2 by N1 is greater than 1. If this entire term is greater than 1, so it means sin I by sin R is also greater than 1 because N2 by N1 is equal to sin I by sin R. So this is sin I by sin R greater than 1. So we can say sin I by sin R is greater than 1. So it means sin I is greater than sin R. which means angle of incidence is greater than angle of refraction. So now we can understand this was entire angle of refraction. Now this part is less. It means angle of incidence is greater. So even if you have to prove this, you can use this. Okay, quickly note it down. Then we'll see from denser to rarer. See, if this medium is denser and this medium becomes rarer, it means N1 is greater than N2. Now, whenever your ray of light is from the denser to rarer, it will always bend towards the normal, away from the normal. So this was towards in the earlier case. Now this will be away from the normal. So this is refracted ray. This is angle of refraction. Now same steps you will repeat. Sin I by sin R is N2 by N1. So N1 is greater than N2. it means n2 by n1, this is less than 1. So sine I by sine R is less than 1. Sine I is less than sine R. So angle of incidence is less than angle of refraction. So this way you can say refraction angle is greater than the angle of incidence now. This way. This is just the proof part. If it is asked to you in the exam, then mention it. Otherwise, just learning these two statements was enough. Note it down. Text me done when you are done. I'll stop the class then. Tomorrow we'll continue on the usual timing that we have.